In this video, we will talk about interacting dummy variables with quantitative variables. So by dummy variables, we're talking about a variable like female, a 0, 1 variable. And when we think about a quantitative variable, we're talking about something that takes quantitative values like experience or education. And we'll try to understand why do we need to interact these two types of variables and what purpose does that serve. So for that, we'll start with our regression model that we had introduced before. This is again a pretty simplistic way of explaining the variation in wages, where we're basically saying that the variation in wages can be explained based on gender and experience. Okay, so now in this type of a model, we know that the intercept for men is beta naught and that for women is delta naught, and we're hoping that the reason we set up such a model is we're hoping to find some difference which is significant between men and women. But since we have introduced experience, the beta naught is basically capturing the returns to experience, but that is common between men and women. And you might have reason to assume that maybe the difference between men and women in terms of salaries actually reduces as both groups gain more experience. So this is to say that if we are thinking about such a model where we're not distinguishing between experience based on gender, we're basically thinking about something like this, where I should use a different color here. Let's take So here we're basically saying as experience goes up, log wages or wages go up, log wages go up for both men and women. But the gap that you find between males and females or men and women is exactly the same. So we're assuming this is a parallel. These are parallel lines based on such a model, right? So this graph only makes sense when this delta is positive and significant, right? So if this is positive and significant, then you would find that there is this gap that exists that doesn't close. But you may have reason to believe that this gap actually closes at higher levels of experience, right? Or at least reduces at higher levels of experience. Okay, so we can ask this question: how do we allow the return to experience, which is this slope coefficient here, beta 1, in the log wage equation to differ by gender? And one way to extend that previous model is to first write out that model. So we say log wage equals beta naught plus delta naught female plus beta 1 experience. So this is exactly the same as before in the previous slide. And then we introduced another term, which is this interaction between your dummy variable and your quantitative variable. Okay, so this is the only thing that changed, right? We introduced this additional term here, which is this interaction, and that's going to give us information about are there changes that we see at different levels of experience between men and women for log wage. Okay, so we can kind of rewrite this equation in this form where we club the intercepts for men and women. So beta naught was the intercept for men, delta naught was for women or females, and then we can take experience to be common here and then write this equation out in this way. And this makes it a little bit easier for us to understand what's going on with males, what's going on with females, and what's the difference between females and males when it comes to the intercept and slope. So this is just based on you putting in the right zeros and ones. So let's take this for instance. If we were to talk about what is the intercept for males, then we're basically plugging in female equal to 0 for the intercept term, right? So if we plug this in to be 0, then this intercept term is just beta naught, and that's what we have here. So similarly, you can figure out the rest of the table. Okay, but essentially the point is that delta naught, like before, delta naught is giving us the difference between females and males, and delta 1, which is this interaction term right here, is giving us the difference between females and males in terms of the returns to experience. Okay, so remember that we're using the letter delta, this letter delta, to emphasize delta or delta 1. These are the differences that we get between the two groups. So we can estimate a model like this with and estimate beta naught, delta naught, beta 1, and delta 1 by just adding that interaction term. You would also note that female times experience is going to take a value of 0 whenever female is equal to 0, right? So we can actually estimate this, and you could try this, but let's work on the interpretation here, and let's say that we got these values, we got these estimates. So here this is telling us that the intercept, this is our delta naught hat, this is 2.098, and the slope is 0.0283. So this is your beta 1 hat. Okay, and this is telling you the intercept for men and the slope for men. Okay, so this is saying that the return to experience for men is 2.8% per year. If we wanted to look at what is happening for females or women, then we would say that the intercept for women is delta naught. I'm sorry, this was beta naught. This should have written beta naught here. And this is delta naught. So delta naught hat. And so the intercept for women is a 2.098 minus 0.518, which is 1.58. And the slope is 0.0283 plus 0.0234, which is 0.0517. So this is basically saying that the return to experience is 5.2% for each additional year of experience for women. Okay, so this is higher. This is higher than that of men. And so you would almost think about that graph that we just drew and think about the fact that maybe the lines aren't actually parallel, but there is this gap that gets closed. I don't know what color we used for females, but basically as there's more and more levels of experience, that gap between salaries is getting closed. Okay, and so we want to focus also on the interaction term and whether it's statistically significant. So here in my model, this is significant at the 10% level, but not at the 5% level with a p-value of 0.08. So you want to be very careful when you're estimating or when you're interpreting the coefficient on female when female and female times experience is in the equation. So if you write out the model again, we're basically saying log wage equals beta naught plus delta naught female plus beta 1 experience plus delta 1 female times experience plus U. Okay, so if we want to look at what are the changes based on gender, so we can take the partial, I mean, if we want to look at what are the what is the effect of being female on wages, then we can take the partial derivative and we get basically delta naught plus delta 1 experience, right? So now what we've done is we've said that the partial effect that being female has on wages actually depends on the level of experience of the person, which is in line with why we introduced that interaction term. So if you look at the coefficients, we can basically then say that this partial effect will equal this once we've estimated the model. So here we're saying that the coefficient on female is negative 0.518, which is the predicted difference between log wage of a female or a male when experience is equal to 0. So if you plug in experience equals 0, and this is the intercept, okay, for okay. And so this is the difference basically. So this is not, I mean, at experience equal to 0 is not very interesting because we're trying to look at what is going on with adding additional years of experience and what's happening to that difference because of that. So what you might want to do is maybe look at what is the difference at the mean. So if you were to calculate what is the partial effect of being female at experience equals 10, I shouldn't write it here, but basically you take the expression that we had before and you plug in experience equals 10, you would get this, right? Which is basically saying that at experience, at 10 years of experience, the women earn 28.4% less than men. Okay, so we could plot something like this and understand what we've done. We basically are saying that if men are the blue line and female are the red line, right, then that difference is less and less, and you could calculate that at different levels of experience. So you can see what is it at 2 years of experience versus 8 versus 10, and you can see that that gap is closing. So for instance, as at 0, that difference is just the that delta naught that you had, which is 51.8%, but then that's reduced to 19% at 14 years of experience. So the gap is not fully closing, and that's what it's also something that we see here. Okay, we've also talked about the centering scheme. So this is something you can do if you really wanted to interpret that delta 1. Instead of doing female times experience, you can just do experience minus 10 in your regression, and then the delta 1 can then be interpreted as the coefficient on female, okay, so at 10 years of experience. And the coefficient is basically, this is a coefficient, but it's really giving you the difference between the two groups, females and males. You can do many other things, or you can add more interactions by introducing, let's say, education or number of years in college as well, and you would see that magnitude, the magnitude of that difference keeps reducing. But you also want to pay attention to the statistical inference. Okay, so yeah, so you could basically set up different hypotheses and test, depending on what the question you're trying to answer, you can basically keep changing your model accordingly. So if the model was, your hypothesis was that there's no difference between men and women, you can basically do an F test on female times experience, and female times college, to suggest that, these are jointly zero, or the effect is jointly zero. You can also set up a null hypothesis which says there's no difference in returns to experience based on gender, in which case you are probably testing, if this was returns to experience and education, then you're probably saying that female experience or female times college jointly are zero. Okay. But remember that it is usually hard to justify omitting the level of a variable. When we say level, we're basically saying, we are including experience or amount of education, like years in college or something like that. If we are omitting these types of variables, it's typically hard to justify an interaction term containing those variables. So typically you would have a regression in which you introduce experience in levels, and then you have some sort of interaction term.